And now let's talk about property number 6, which says integral 0 to 2a fx dx equals to integral 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Right? Now the trigger point to consider using this property is limits like 0 to 2 pi, 0 to 4 pi, or max to max 0 to 8 pi, max to max. Beyond that, we probably might be using periodic property, right? But you have to consider using this property till 8 pi only, right? Don't go beyond that. If limits are beyond that, then probably you have to use periodic property, okay? And now let's solve this example. We have I equals to integral 0 to 2 pi sine 4x dx equals to k times integral 0 to pi by 2 cos 4x dx. Find the value of k. Now, before moving forward with this question, let me tell you one thing. Whenever you see integral of this type 0 to pi by 2 sine x dx, sine square x dx, sine cube x dx, sine 4x dx, whatever, or integral of type 0 to pi by 2 cos x dx, cos square x dx, cos cube x dx, cos 4x dx, etc. You have to be very comfortable in thinking that these two are exactly same. Why? Because if you use the property integral a to b fx dx equals to integral a to b f of a plus b minus x, you can see that these two actually are equal. So if this has been asked, you have to assume this also. If this has been asked, you have to assume this also, right? And now let's solve this question. So over here we can see that we have this trigger 0 to 2 pi for property 6, right? Also, when this has been asked, you have to assume that they're also asking 0 to pi by 2 sine 4x dx because of the property of a plus b minus x, right? So if they're asking this, they're also asking this same thing, right? So we can see sine 4x over here as well. We have sine 4x over here as well. So that gives us multiple triggers that we have to use property 6. Okay. Now we have I equals to this. We have I equals to this. So with the help of property 6, we can write I as 0 to pi. Basically 0 to 2a. This is 0 to 2a. We have converted that into 0 to pi. Basically 0 to a. Okay. Sine 4x dx plus integral 0 to pi sine 4 2 pi minus x dx. That is 2a minus x dx. Right? Okay. Now we know that sine of 2 pi minus x is nothing but minus sine x. But since we have the even power over here, so it becomes sine 4 2x only, sine 4x only. Okay. So this becomes integral 0 to pi sine 4x dx plus integral 0 to pi. This becomes sine 4x dx only, right? So this becomes 2 times integral 0 to pi sine 4x dx. Now what we have got, we've got I equals to 2 times integral 0 to pi sine 4x dx. Again, we can use the same property, right? This becomes 2 times integral 0 to pi by 2. Basically, now this becomes 2a. So it becomes 0 to pi by 2 sine 4x dx plus integral 0 to pi by 2 sine 4 pi minus x dx. We know that sine of pi by pi minus x is nothing but sine x only. So this automatically becomes sine 4x. Okay. Now this becomes 2 times integral 2 times 0 to pi by 2 sine 4x dx. Okay. So this becomes 4 times this thing. So k is 4. K equals to 4. This is the answer, right? And now let's solve this example. We have integral 0 to 2 pi sine 100x cos 99x dx, right? Now again we have the trigger 0 to 2 pi over here, which is indicating that we might have to use property 6. Okay, so let's use that. We have I equals to integral 0 to 2 pi sine raised power 100x cos raised power 99x dx, right? So if you apply property 6 over here, we'll be getting I equals to integral 0 to pi sine raised power 100x dot cos raised power 99x dx plus integral 0 to pi sine raised power 100 2 pi minus x dot cos raised power 99 2 pi minus x dx. Now we know that sine of 2 pi minus x equals to minus sine x, and we also know that cos of 2 pi minus x equals to cos x. Okay, we have a negative sign over here, we have a positive sign over here, but since we have an even power over here, so it doesn't matter, right? So this automatically becomes sine raised power 99x dot cos raised power 100 99x dx, right? So this actually becomes 2 times integral 0 to pi sine of 100x dot cos of 99x dx, right? And now if you apply the property 6 once again over here, we'll be getting I equals to 2 times integral 0 to pi by 2 sine 100x dot cos 99x dx plus integral 0 to pi by 2 sine 100 pi minus x dot cos 99 pi minus x dx. Now we know that sine of pi minus x is nothing but sine x, and cos of pi minus x is minus cos x. So this one stays the same. This becomes sine of 100x, sine raised by 100x, and this becomes minus of cos raised by 99x, right? So this and this entirely gets cancelled out. So answer is 0. Okay. And now let's solve this example. We have integral 0 to 4 pi dx upon cos square x 2 plus tan square x. And I'll keep this as homework because we have the same kind of triggers over here, 0 to 4 pi. That is indicating that we have to use property 6. Okay, so that's why I'm keeping this as homework. So today's lecture was till here only, and in the next lecture we'll be talking about limit of a sum, Leibniz theorem, and periodic property. So let's meet in the next lecture. Thanks for watching.